Okay, now let's tackle finding molecular formulas from empirical formulas and molar masses. So here are the notes for this. It's good to remember that the empirical formula is the simplified ratio of atoms bonding. So if the empirical formula is the simplified version, then the molecular formula is a multiple of the empirical. And by multiple, I literally mean a whole number integer, like 2. Like the molecule might be twice as big as the empirical formula represents. It might be 3 times as big, it might be 5 times as big. But it will be in the same ratio as the empirical formula, but because the empirical formula has that ratio simplified as much as possible, then the real molecule is in that ratio, but some larger multiple thereof. And here is going to be our 3-step process. Step 1, find the mass of the empirical formula, using the masses on the periodic table, of course. 2, compare that to the molecular mass and literally just divide the larger number by the smaller number. This will get you what I call a factor. Multiply subscripts by that factor. So the subscripts in the empirical formula, multiply it by that factor. If that factor is 2, you're doubling it. And the molecule happens to be twice as heavy as the empirical. It's not always 2. Now, one of the questions on your test involved this. It was question 20. Question 20 for everyone. Question 20 said, determine the molecular formula for a compound that has the empirical formula CH2O and the molar mass of 120 grams per mole. I can tell from that 120, the fact that there's no decimals, that that number is rounded. So when I deal with masses, I'm going to be okay with rounding it. This little box is something that we've used to work the process. You don't have to use the box though, as long as you work the 3-step process that you just put in your notes. So here's what's given. They gave us the empirical formula, CH2O. So whatever this molecule looks like, it will be in a 1 to 2 to 1 ratio for carbons to hydrogens to oxygens. And this is ultimately our goal right here. They also gave us the molar mass. That's the mass of the real entire molecule, 120 grams per mole. Now, I don't think CH2O weighs 120. The real molecule is definitely much larger than the simplified version. So, step 1 says, find the mass of the empirical formula. Okay. 12 plus 1 plus 1 plus 16. That's just me taking the masses off the periodic table. And like I said, I'm rounding. Obviously, I'm rounding. So the simplified version weighs 30. The real molecule weighs 120. So it might be obvious, or I might just grab a calculator and divide. 120 divided by 30 is 4. So the factor that I just found in the second step is 4. And if you punch this into your calculator and you're using decimals, if you get like 3.999 or something, round it to 4. You're looking for a whole number here. Okay, you are not done. Some of us got this far and we found 4, and then we stopped, and 4 is great, but what we want to know is what's the molecule? What does the molecule really look like? What is the molecular formula? So I take this invisible 1, that 2, and that invisible 1, and I quadruple all of them. C4, H8, O4, and that is the answer. There's the molecular formula. Now, this is the only problem on your test of this type, so go ahead and try this process for this additional problem.